Welcome, Bill. We are so happy to have you as a speaker at the symposium. It is an honor to have your experience and knowledge in this event. We will open for your question at the end of your speech. Thank you very much. First, I will present you to the audience. Para nuestra audiencia, Bill Inmon es conocido como el padre de las bodegas de datos. La verdad, él ha escrito más de 70 libros en 9 idiomas. Uno de sus libros más conocidos es Construyendo el Data Warehouse, que ha vendido más de 500,000 copias. Bill fue nombrado por Computer World como uno de los 10 líderes de opinión más influyentes en la historia de la informática. Bill desarrolló la tecnología para la desambiguación textual, que lo que hace es leer texto, procesarlo y convierte ese texto en una base de datos estándar. Bill fundó y sacó Prim Soluciones, que es una empresa que originalmente era ETL. Y bueno, yo realmente pienso que presentar a Bill es uno de los grandes honores que tenemos y que la mayoría de nosotros pues sabemos quién es él. Hoy nos va a compartir su experiencia a través de una conferencia que se llama Data Lakehouse, qué es y cómo ha evolucionado desde el Data Warehouse. Hi, Bill.
Okay, first off, I want to thank everybody for being here. It's a pleasure and honor to speak to you today. It's been about 6 years since I was in your country, and I hope to come back soon. Um, I want to talk with you today about what I think is a very important topic, and that is making a business value out of artificial intelligence. There's a lot of artificial intelligence out there that is very interesting to look at, but trying to find business value out of it is a bit more difficult to do. So I want to talk with you today about how to get business value out of artificial intelligence. The best way that I know how to get business value out of artificial intelligence is to go where there is information that business values. And what information does business value? Business always values information that is close to money. The closer you are to making a sale, finding a new customer, the better off you are in terms of making something useful out of artificial intelligence. And the best way that I know how to do that is to look at text. Text is a wonderful place to find business value. Why is text an important place to find value? It's important because people, as they do business, speak. And once you're able to listen to your customer, and I don't care what business you're in, you can be in any business. Whatever business you're in, listening to your customer is something that is extremely important. And so, how do you listen to your customer? Well, your customer can be heard in lots of places. Your customer can be heard over the internet. Your customer can be heard in terms of email. Your customer can be heard in terms of call centers and voice recordings. Your customer can be heard on printed paper. There are many, many places where you can hear what it is your customer is saying. And so that's where you start to hear and what do you listen for when your customer is talking? What you listen for is what does the customer like and what does the customer dislike? Because once you understand what the customer likes and what the customer dislikes, you are going to be able to make more sales and get more customers and keep the customers you have. So listening to your customers is something that is a very important thing to do. In fact, I really can't think of anything more important than that. So how do you listen to your customers? And again, it doesn't matter what business you're in. You can be in manufacturing, you can be retailing, you can be in any business. So how do you listen to the voice of your customer? Well, there's artificial intelligence out there now called textual ETL. And what textual ETL does is textual ETL allows you to capture the text that is being of interest to you, take that text and turn it into a database, and then listen to what the customers have to say. Let me tell you a little story, a true story about listening to the voice of your customer. This is something that happened to us a number of years ago. A number of years ago, Nike, the shoe company, uh, one of the managers in marketing came to us and they said, Bill, we have a problem. We're losing market share to Adidas and we don't know why. Can you help us out? Now, we were a very young company at the time, and we were looking for ways to prove the value of working with text. So we went out to the internet and we got the comments that people make on the internet from 5,000 Nike people, customers, and 5,000 Adidas customers. And we took that information, that textual information of what people were saying, and we put it through textual ETL and made a database from it. And from that database, here's what we found. We found that Adidas appears to be a very well run, very normal company. We didn't find anything unusual with Adidas. But we went over to Nike and we found something that occurred in probably 40% of the people that were talking about Nike on the internet. And what we found was this: people were saying, "I bought your shoe, I wore it for 3 weeks time, and then it disintegrated. It broke in two, and now Nike won't replace my shoe. I only had it for 3 weeks time, and it no longer is a shoe. I will never buy another Nike product again." And this went on for approximately 40% of the 5,000 customers that we were talking with. So what happened was we sent a report back to Nike Marketing Management, and we said we found that people are unhappy with the shoes that you are producing because they tend to break or disintegrate very quickly, and you won't stand behind them. And Nike Marketing Management had an amazing response. They said, "Oh my gosh, this is embarrassing. We can't let anybody find out about this." And I thought, that's interesting. You would think that they would want to find out why their shoes were having a problem. Instead, they wanted to put everything in the garbage can and act like it never happened. So we wrote a letter to the president of Nike Shoes. We said, "Dear sir, we are an independent agency. We have analyzed your data and we think we have some interesting information for you that you ought to know about." And so we sent, it was a nice letter. It wasn't a bad letter or anything like that. We were simply trying to inform him of what his customers were saying. And we got two weeks later a letter back from the president of Nike. He said, "Dear Mr. Inman, we work with certain consultants. You're not one of them. We don't ever want to hear from you again." And so it said, oh my gosh, you would think that a company would want to know if there was a problem with the product they're producing. But apparently Nike didn't. Well, the story continues because about 6 months later, there was a famous basketball game in the United States. It was between two universities, Duke University and North Carolina University. It had the largest television audience in the history of basketball games on TV. Even the President of the United States attended the game. I understand they estimate there were about 50 million people watching the game. It was a very popular event, much like soccer or football would probably be in your country. So, anyway, in the first 60 seconds of the game, the star from Duke University was running down the floor in his Nike shoe, and his Nike shoe blew up. He stepped on it and it disintegrated. It hurt him, his foot. He had to leave the game. And so, there in front of 50 million people and the President of the United States, the star of the show in a Nike shoe blew up in front of all of those people. The next day on the stock market, and this is the truth, Nike's stock dropped by $2 billion, not 2 million, $2 billion, because all of these people had seen the problem that Nike had with their shoes. Now that's a true story, and that's what happens when you don't listen. If Nike had listened to what their customer had been saying, they never would have had this problem. They would not have lost $2 billion on the stock market. So that's just one example of many, many examples of the importance of listening to what your customer is saying. And you can do this today with artificial intelligence. You can take information about what people are saying. You can get it from the internet. You can get it from email. You can get it from all of these different places. You can put it through textual ETL. And now you can find out what your customer is saying. And there are many, many other examples of using artificial intelligence to look at text and find out what's going on in your organization. Let me give you another example of using artificial intelligence and text analytics and finding something useful. Most recently, all over the world, had a disease called COVID. And COVID was a horrible disease. It affected a lot of people. It was also a disease that the world didn't know anything about. So, so how do you go about trying to find out about COVID? Well, one way to do it is to get doctors and scientists and try to get them to do experiments and whatever. And that's how it was done. And that's a very long, complex, not very fruitful way to attack a disease. Another way to find out how to address COVID is to take the doctor's notes from people that have had COVID, put them all together, take 100,000 patient notes, put them together, and then you can ask such questions. How does COVID relate to smoking? How does COVID relate to a person's age? How does COVID relate to a person's gender? How does COVID relate to the weight of a person? That if you've got 100,000 doctor's notes, you can sit there and say, what are the factors across all of the people that have had COVID that we need to know about? The problem is, doctor's notes are in the form of text. You can't do that with doctor's notes. What you need to do is take the doctor's notes and put them in the form of a database, because once you put them into the form of a data, doctor's notes are designed for one doctor and one patient, and they're written in text. And for the purpose of one doctor and one patient, they work just fine. But if you've got to look at 100,000 patients or 1,000,000 patients all at once, you can't do that with text. You've got to have it in the form of a database. So whether it's Nike trying to sell their shoes, or whether it's a doctor trying to help people with COVID, being able to go from text to a database uh, is what you have to do, and you do that through artificial intelligence, something known as textual ETL. So that is now, as you can suspect, there's a lot more to this subject. That how do you work with the data? Let me just talk a few seconds about the difficulties of working with text. Text is perhaps one of the most difficult subjects that you'll ever work with in your life. And why is that? The reason for that is that text is inherently complex. Let me give you just one complexity of many, many complexities. Suppose I were to say to you the word fire. What does the word fire mean? Well, it could mean that my house is burning down and it's on fire. That's what it could mean. Or it could mean that I've taken a gun out and pulled the trigger. I've fired the gun. Or it could mean that my boss is mad at me and he walks in this morning and says, "You're fired." So if I give you nothing more than the word fire, you don't know what that means, because it can mean lots of things. And in order to understand what the word fire means, you have to have context. And so that is just one of many, many difficulties that there are with text. Let me give you one more really simple one. In the United States, we spell the word color COLOR, but in England, they spell the same word COLOUR. That's how the English spell the word. Now, it's the same word, it's just spelled differently. But in order to make that connection, you've got to explicitly tell the computer that COLOR is the same thing as COLOUR. So and we don't have time. You don't have time, and I don't have time for me to tell you all of the different things that have to occur when you are dealing with text. Suffice to say, it is an extremely complex subject, and it's like it's like walking on sand. That if you're going to be a runner, you want a track that's nice and firm. But when you walk on sand, every time you put your foot down on sand, you slip just a little bit. In some cases, a little bit. In some cases, a lot. But there's no firm footing on sand. That's what text is, as opposed to the sidewalk or the street. There's firm footing on sidewalk or the street. So I'm looking at my time. I was allocated 20 minutes to talk. I now have, if you want more information, I suggest two places to look. There's a website called Forest Rim Technology and another website called datavox.ai. Now there's two datavoxes out there on the internet. The one that you want to look at is not the .com, you want to look at the .ai. So if you're looking for more interesting information, there's where you can find more interesting information. So with that, I'll open up the floor for any questions you might have, and I'm happy to try to answer them.
Thank you, Phil. ¿Tenemos preguntas? Yo no estoy viendo preguntas en el chat. I am asking them if they have questions.
Puedo hablar español un poquito.
Ah, qué
Bien.
bien, Bill. Well, I have a question, Bill. What do
Yes.
you think is the importance of data strategy in artificial intelligence?
Artificial intelligence today is very interesting and very, we call it in America, very cool. But you've got to be careful with artificial intelligence because it's very easy to get lost in artificial intelligence and not find business value. You've got to be focused first on finding business value, then using artificial intelligence for it. So in a lot of ways, artificial intelligence is like a toy. It doesn't have to be like a toy, but I can't tell you the number of people that I've said, gee, Bill, we've tried to use artificial intelligence, but in terms of improving the business that we have a hard time doing that. So if I have to give you any advice at all on artificial intelligence, start with looking for business value, then use artificial intelligence. Don't start with with artificial intelligence and try to find business value.
Thank you, Bill. We have other question. The first one is, what literature is used for starting learning about textual ETLs?
There's a book that I can recommend for you. It's called Turning Text into Gold. And it's been out a number of years now, but it tells you all about textual ETL. The publisher is Technics, Technics, Technics publication, and there is a very good description of textual ETL in that book. And it's not an expensive book; it's a small book.
Okay, thank you. Other person is asking you if you could write the reference here in order to find more information about it, please. They want that you write
Yes.
in the chat. I don't know if you could do it.
Maybe I can and maybe I can't. Chat, okay? Here's the chat. Okay. Okay, I'm in chat. Okay. What are data warehouse crucial for modern organizations? Oh, why are data? Now that's a very good question. Data warehouse is useful if you want to look at data across the corporation. Let me tell you some things. Originally, applications were written for one user, for marketing or sales or some purpose like that, selling a product or something like that. And then people discovered that they needed that data in places other than where the application was written for. They need it in finance, they need it in accounting, they need it in marketing, they need it in sales, they need it in engineering. And the problem is that all of these applications were written for a specific purpose. And when you tried to put the applications together, you couldn't do it. It was like trying to glue a glass onto rock. I don't think you can glue glass onto a rock. I don't know. Maybe you can, but I don't know how to do it. But so what happened is if you have a need for people across the organization to look at the data, that's when you need a data warehouse. And that need appeared 25 years ago, and it hasn't gone away today. It's still with us today. How important is it to hear what the customer doesn't tell us? That's actually quite important as well. But that, if you want to find out what your customer isn't saying to you, you first have to find out what your customer is saying to you. And I have to say, some of the more interesting examples I've ever seen have not been what people have been saying, but what they haven't been saying. But the starting point for finding out what people aren't saying is to look at what people are saying. I have to say, it's very difficult to find out what people aren't saying. That's it's very difficult. It can be done. I'm trying to think of. We did it in a restaurant, and in the back of my brain, I know something, but being an old guy, I can't remember it right now. So, okay. Um, There are market failures all the time for many, many different reasons. And the sooner you find out that there's a problem before there's a failure, the better off that you are. But markets fail for many, many different reasons. They fail because of economic conditions. They fail because of competition. They fail because the product has grown old. They fail because the people don't want to buy the product anymore for whatever reason. And so if you're dealing with market failure, the best thing you can do is listen to your customer, because if you listen to your customer, you will get an early warning as to failure. If you don't listen to your customer, you're going to fail and then wonder why. And if I'm going to have a failure on my hands, I want to know as soon as possible, not after I'm 6 feet under and they're burying me.
Bill,
Yes.
Henry is asking you about to how to control, measure the validity and transparency of data in data lake.
Okay. I have to answer this question a little bit indirectly. First off, there is a major architectural difference between a data lake and a data lake house. And they sound the same, but they're not the same thing at all. So if you're talking about a data lake, not a data lake house, uh, uh, I have never seen one success story with a data lake. There are many, many problems with data lake. In a data lake, you simply take data, throw it in a pile, and hope somebody can do something with it. And that's a formula for disaster. And over and over, I can't tell you how many people said, gee, I tried building a data lake. It was easy to build, but nobody could use it. And it soon became a liability. Now, a data lake house, again, sounds like a data lake, but it's not the same thing at all. A data lake house, on the other hand, has number two, lots of different features. Two of the more important differences between a data lake and a data lake house is in a data lake house, number one, you've got to integrate the data before you put it in the data lake house. You don't just throw it in the data lake house, you put it in so that the data can be used with other data and so that people can actually use it. The second difference between a data lake and a data lakehouse is that in a data lakehouse, you've got something called the analytical infrastructure. You've got a directory telling you where the data is, and so you can actually find data and use data in a data lakehouse. The other day, I was talking. I'm not going to name the company with a very large company, and they had 6 petabytes of data in their data lake. And they say, Bill, nobody ever uses this. Do you know how much 6 petabytes of data is? That is a lot of data. And they just get lost. when they try to use it. So if you're talking about a data lake, then I don't recommend a data lake for anybody. If you're talking about a data lakehouse, I do recommend a data lakehouse for people. I do suggest that there's some books that are out there on the data lakehouse. I suggest that you should read some of the books on the subject. I hope that answers the question.
Okay, and we have other question. Is which tool do you recommend to implement a data lakehouse solution? Databricks is a good tool, but in our region, I think it's not common tool. This question is from Juan Andres.
Um, I really have a difficult time answering the question, but I'll give you the best answer that I know how to give. When you look at a data lakehouse, I mentioned that the data needs to be integrated before you put it in there. It- there are three major types of data that are found in a data lakehouse. There's classical structured data, there is textual data, and there is analog data. I assume you know what analog data is. Analog data is data that's generated by a machine. So there are three different kinds of data that go into a data lakehouse: structured, textual, and analog. For structured data, the classical tool that I tell people to use is some form of ETL, extract, transform, load. And there's a fair number of ETL tools that are out there, and they're good for your data lakehouse. For your textual data, there's textual ETL, and I'm not aware of any other tool other than textual ETL. So that's pretty much what you need. For analog data, analog data has some very different properties than any other kind of data. Uh, Let me give you an example of the properties and why analog data is different. For the next few minutes, suppose that you are a security camera looking at a parking lot. So you're working for some company and you're a security camera and you're looking at the parking lot. Uh, 24 hours a day, you sit there and look at and surveil what's going on in the parking lot. At nighttime, things are very boring. During the daytime, people come and park their cars and get and leave their car and go to work. So that's what you see as a security camera. And how interesting is an empty parking lot or people parking their cars? It's very uninteresting data. How much of the data there is there? A tremendous amount. However, one day somebody has their car broken into, and somebody's gone into the parking lot, broken into the car. The whole amount of pictures you take of somebody breaking in the car is about 3 minutes worth of taking pictures. So here you've sat there for a month's time, taking picture after picture of the parking lot, and that information is not useful really at all. On the other hand, the 3 minutes that someone goes into a car, breaks into the car, and does whatever they're going to do, that information becomes very important. So, analog data has the property that the vast majority of analog data is of little or no interest, and some of, usually a small percentage of analog data is something that is extremely useful. That you need to find the person that broke into your car. So that's the nature of analog data, having a huge amount of data that is not of any great interest, having a small amount of data that has great interest. So how do you deal with structured data and textual data? We have something called ETL, and those things work quite nicely for the purpose of getting data into your lakehouse. However, when it comes to analog data, you have a completely different process. You have what's called distillation process. The distillation process says, I'm going to read the data from my analog environment, and I'm going to be selective and only find the data that's of interest. Now, stop and think how the police do it. How do the police handle the data that they get off of a video surveillance camera? So here you are in a police station, and you've got a week's worth of data from somebody's camera. What do? Well, some poor person has got to sit there and watch every byte of data that comes across that that camera because you never know where the break-in is going to occur. So the way the police do their distillation is to sit there and by the way, I would not like to have that job because after about 6 hours of looking at a screen, I go crazy. I couldn't do it, but there are people that can do it. So that's what we mean by distillation. So when you get ready to put data into a data lakehouse, number one, you use ETL for structured data. You use textual ETL for textual data. You use a distillation process for analog data. That's what I recommend to people. Um, and so I hope that is of interest to you.
Okay, Bill, we have the last question.
Okay.
Is this Andres Felipe ask you? There are some strategies for listening to what the people don't say, like sentimental analysis or gestures using artificial vision and artificial listening. But it is kind of scary to think about robots looking at us with enterprise purpose. So how can we prevent artificial intelligence tools to be used for people controlling or manipulation?
If I had a good answer for you, I would be the president of my country. The answer is I don't know. And the thing about artificial intelligence is it's still very new. It's still the world in Colombia, United States, Europe, everywhere. We're still just learning about artificial intelligence. Um, 5 years from now, we'll be able to answer that question nicely. Today, I'm not sure. I know certainly I don't have the answer, but I'm not sure anybody has the answer to that. So thank you for the question. I don't like to say I don't know, except that I don't know.
Thank you, Bill.
Okay.
Do you, Henry is asking other question. Do you have time to ask him?
Sure.
Okay, Bill, how do you see the difference between your theory and the Ralph Kimball theory, uh, talking about data warehouse architecture?
Okay. Um, I've been asked that question before. In fact, many times. The truth of the matter is that people use a combination of the Inmon approach and the Kimball approach together. The Inmon approach is good for gathering data into an integrated form that reflects the whole corporation. The Kimball approach is good for taking that information and customizing it for an organization, marketing, sales, finance, engineering, management, or whoever. And the truth of the matter is, and I talk to many people about this all the time, that people use the two the approaches are very different and they serve different purposes. The Inmon approach serves to integrate data across the corporation. The Kimball approach creates something that is optimal for analytical processing, but it draws upon the data that's been collected and reflects the organization's data. So I personally I don't see any conflict between Kimball and Inmon. I think they work together, and that's my opinion.
Thank you very much, Bill.
Okay.
We are so happy that you were with us. Thank you very much for your experience, your knowledge. We are so happy to have you here, and we will see you soon.
Yeah. And invite me to South America. I'd love to come again.
Oh, it's great. We will do it. Thank
Okay.
you very much.
Thank you.
Bye, Bill.
Bye bye.
Muchísimas gracias. Esperamos que hayan disfrutado muchísimo de estas primeras conferencias y nos vemos luego. Hasta luego. Gracias.